Hello, today I am going to discuss about sequencer output instructions in Allen Bradley PLC. So let me create a new file. Okay, and I insert virtual switch, and then I will click the file shift of sequencer tab, and then I will select this SQO or sequencer output. Then I drag to here. Okay, let me assign the address. I will use digital input colon slot 0 slash bit 0. Okay, so this sequencer output, just like the first in first out, load, unload, etc., it need the word address for file, destination, and control. Okay, so what is sequencer output instructions? So these instructions, when activated or energized, it will transfer the words from this file, okay, this index file word address, to the output destination address, which is a digital output, sequentially. I will show you later. Let me assign the address. Okay, so this I will assign with the binary address. Okay, so this word address is an index address, so I should start with hash, then binary b3 colon 0. Okay, so this is the word address, and then the mask. Okay, the mask, if the particular mask bit is set to 1, then the particular bits of the intended file will be activated. If it is set to 0, then it will be ignored for the operation. Okay, so let's say I will use the first 5, 1, 2, 3, 4, 5, the first 5 bits. Okay, and then I want to ignore the rest of the bit for the operation, so I will set the mask to 1 1 1 1 1 here. So in hexadecimal format, okay, the first 4 bit is 1 1 1 1 equivalent to F, so the fifth bit is 1, so I will type Z0 1 F followed by H. Okay, the small capital letter H stands for hexadecimal, so this number is in hexadecimal format. Okay, the destination is my output destination, which is a digital output. All right, so it will be the address will be digital output column slot 0 dot word 0. Okay, so this is the word address. If I type slash, it will be bit 1, bit 2, bit 3, and so on. Okay, so if I type dot 0, so the dot after the dot, it will be the word. Okay, this is the word address. So the control, you can assign any control address. Okay, as long as it's the word address. So the length is, I will use maybe 5. Okay, it's up to you. The position is a starting position. You can leave it as 0. Okay, so now let us compile the file to make sure there's no error, and then we can download. Okay, we save the programming into your computer hard disk. Okay, let me name it sequencer output. Save. Then click here and click run to run the program. Let me pull this one to the right. Okay, I open the binary file. Okay, I also need to open the digital output. Okay, this one I will zoom it. All right. Okay, let me set the sequence. Okay, so let's say this one I will set to 1 1. Okay, what is SQO? SQO, or sequencer output instructions. It is the instruction when energized or activated, it will transfer the words from this file word address, which is hash binary b3 column 0. This one, binary b3 column 0 word, okay, sequentially or one by one to the destination output address, which is this one, digital output column slot 0 dot word 0. Okay, this one, digital output colon slot 0 dot word 0. Okay, so in other words, sequencer output instruction, when it is energized, it will transfer the word value sequentially or one by one to the digital output. Alright, so the mask bit here is used to set which bits you want it to be activated. Okay, for example, 001F. H. H is a hexadecimal format. So hexadecimal format, we need to group the 4 bits into one group in order to find the hexadecimal value. So F means the 4 bit F is 1111. Okay, 1 here, okay, 1 2 3 4 is here 1. So 11111 here will be activated. So since this 5 bits is activated with the mask bit, so this 5 column will be used for the sequencer output operation. The rest of the bit will be ignored because it's set to 0. Alright, okay, so to repeat what I said just now, the sequencer output instruction, when being energized, it will transfer the words from this file, okay, B3 column 0, sequentially to the digital output column 0.0 here. Okay, so let me demonstrate for you. When I energize this sequencer output, this first word value will be transferred to here, which is 1. Then I will energize one more time. The second word's value, which is 1 will be transferred to here 1 and so on. Okay, so the length is 5. That means it got 5 words. Okay, 1 word, 2 word, 3 word, 4 word, and 5 words. Alright, okay, let me energize. You can see what happened. This one will be transferred to here. Okay, you can see the position is 1, which is here, position 1. Alright, let me de-energize and then energize one more time. Then this 1 will be transferred to here, 1. See, position 2. Okay, transfer from position 2, 1 will be transferred to here, 1. Okay, if I de-energize and energize one more time, see, 1 will be transferred to here. Okay, 1 is transferred from the binary file, binary address to the digital output. You can see, so the position is 3, which is here. All right, Okay, let's say energize one more time. 1111 is transferred to digital output. The energize one more time and then energize. So 11111 is transferred to digital output. 11111. If I energize again, this will be set to 1. See? Position 1. And then you can repeat the same process. Okay. So that's it. Thank you.